In this lesson, we're going to be learning about data type conversion functions. So if you recall in the last lesson, we learned that information and data can be represented within your programs through many different types. And the reason we have all of these different types is because different pieces of data take up different amounts of space. And the data type tells Python how much computer memory to set aside to store that piece of information or data. Now you may be wondering, how can we convert between these different types of data within our Python programs? And the answer to that can be solved using data type conversion functions. And there's 4 of them, just like there's 4 primitive data types in Python. So the first function is int. So this function converts whatever value you pass into it into an integer. So in the first example, we pass in this string that contains 32 in it. We pass that into the int function and it returns the integer 32. In the next example, however, we pass in the string hello. Now we're going to get a value error back because it's an invalid literal for int with base 10. So basically Python can't find a number in this string, so it's going to return an error. Negative 2.3 returns negative 2. The next one's a little weird, and if you pass 3.9999 into the int function, you're going to get 3 back. Reason being, when Python converts a decimal number to a whole number, basically what it does is it cuts off all the decimal points. It doesn't round. It does something called truncation. It just chops off the decimal points. The next one, again, we just pass in the string containing the number 42, and that returns the integer 42. And then in the last one, 1.0, Python chops off that 0.0 and just leaves us with 1. Float, kind of similar, converts the inputted value into a float. So we have the integer 32 being passed in, and you can see Python just adds the 0.0 to it. So you get 32.0. We pass in the string 3.14159, and we get the float back 3.14159. And if we pass in the integer 1, we just get 1.0. Python just adds that 0.0 onto it. And the string function converts whatever value you pass into it to a string. So you pass in the integer 32, you get a string representation of 32. If you pass in 3.14149, you get the string 3.14149. If you pass in a Boolean, whether it be true or false, you get a string representation of that Boolean back. And then in that last example, we pass in true with a lowercase t, and that's not recognized in Python as an actual value. So what Python is going to do is it's going to look for a variable called true. It's not going to find one, and so you're not going to be able to get an actual result. So you're going to get a name error saying that name true is not defined. And the last function is bool. So Python assigns Boolean values to values of other types. So for numerical values, any non-zero value is going to be true, and any zero value is going to be false. For strings, any empty string is going to be false, and non-empty strings are going to be true. So in the first example, we pass in 1, and we get true. The second example, we pass in 0, we get false. For the third example, we pass in a string with ni exclamation mark. Those are 3 characters within our string, so it's not an empty string, and thus we get true. And then in the next example, we pass in an empty string. It's empty because there's absolutely nothing in it. It's just a quote followed by another quote. If you have a space in it, a space actually takes up space in memory, and thus that would be true because it would actually have a character in it. Bool 3.14159 is going to return true because it's a non-zero value, whereas 0.0 is going to return false because that just evaluates to 0. Let's take a look at this in PyCharm. So here I have a program. The first 2 lines, I initialize 2 variables, num1 and num2. Num1, I assign the string value of 10. In num2, I assign the integer value of 10. So what I do here is I just print the data type for each one. I call the type function, which basically just returns the data type as a class. It returns the data type of the passed in object, and then we print that data type. So let's go ahead and try and run this. And you see we get the first line. So this line runs and we get the data type of num1, which is a string, class str. And then here we get the data type of num2, which is an integer, class int. However, once it reaches this line, we get an error. Python says we get a type error, must be str, not int. So we can go ahead and fix this by using one of our data type conversions. So we can do one of two things. So since num1 is a string, we could convert this to a string using the str function. So if we just pass that into str, save it, and run it, you'll see we get an actual value back. Now, what's going on here, you'd think that Python would add these values together, but since they're both strings, Python can't actually do arithmetic with it. So rather, it does something called concatenation, where it just kind of combines these two together, kind of sews them together. The other thing we could do is, rather than do string concatenation, if we left num2 as an integer, we could convert the string num1 to an integer. So we could call the int function on this. We could save it, and then we can run it. And you see this actually does the arithmetic, and we get the value of 20. So why do we need to use these functions? Go ahead and try this. We just did something similar to this in the editor, but go ahead and copy this line down. I'll wait. If you run this, you're going to get this error again. Must be str, not int. It's a type error. So this introduces a concept called polymorphism. More specifically, it introduces a branch of polymorphism called operator overloading. So what the heck does that mean? A general definition of polymorphism is that it's something that has the condition or the ability of something to occur in several different forms. So a polymorphic data type is one whose operations can also be applied to values of some other data type or data types. So use of the same operator for different data types to get different behavior because of this. For instance, this line would not work because you're dealing with two different data types. So you're dealing with a string on the left of the plus sign and an integer on the right of the plus sign. So that would return the type error. Whereas this would work because you are dealing with the same data type. So when you're dealing with two integers, the plus sign has a different function than when you're dealing with two strings. So when you're dealing with two integers, this is going to return, it's going to actually do the arithmetic, and it's going to produce 9. Whereas if you do 7 as a string plus 2 as a string, it's going to perform a completely different operation because the operator is being called on two different data types. So this is actually going to concatenate these two strings together to produce the string 72. So this probably doesn't make a whole lot of sense to you right now, and that's okay because we're going to kind of come back to this throughout the course, and we're going to kind of talk more about this when we get into objects and whatnot, when we start talking about classes. I just wanted to kind of put this in your mind to get you thinking about this.